Hi, today we are going to learn to rewrite equations or rearrange equations. They are also called literal equations. However, we're going to really concentrate on solving for y right now or rewriting for y. So I'm just going to show you um, one equation that can be done both ways. And then we're going to go and solve for y in most of the equations. Now, I say solve for y, you need to understand that we're basically rearranging the equation so y is all by itself, or whatever letter they ask for. So up here, we're going to do a 3y plus 4x equals 9 for x, and then we are also going to do it for y. All right, so the first one that we're going to do, I'm going to do in green, so we have two different colors going on. We're going to solve for x. So I have 3y plus 4x equals 9. And basically what I would like to do is isolate this x because that's what it asks me to solve for. Now, the reason why we have to rearrange or rewrite the equation is because we cannot solve it because we don't have a number to put into either one of these to get the other answer, okay, to get the other variables value. So right now we are going to treat whatever we're not solving for that's together with the other variable sort of like a constant so that we can move it around. So just like if this were just a 3 and not a 3y, what I would do is I would move it over here because I want x to eventually be by itself. So this is a positive 3y, so I'm going to subtract 3y. This goes to 0. This 4x comes down, and I can only line these up. They are not like terms, so I cannot do anything else but that. I still want this x to be by itself. And right now, I got this pesky 4 multiplying by it. Okay, so the opposite of multiplication is division. When I divide, I want to divide everywhere. 4 divided by 4 is 1. So I get x equals negative 3/4 y plus 9/4. We got x all positive and by itself. Okay? I know that's weird. Remember that we're not solving anything like getting a y equals 5 or an x equals negative 7. We are just rearranging an equation. Okay, now we're going to use this same equation and we're going to solve it for y, because I think instead of trying to do two different things, it's way better if you see it with the same equation. This time we are trying to solve for y. So what I need to do is I need to get this 4x to go over, because if it was 3y plus 4, and not an x there, you would say, oh, that's a positive 4. You're going to subtract it from both sides. Same thing. We're going to treat this whole unit, this whole term, like a constant. So we're going to scooch it over here by subtracting. 4x minus 4x is 0. So we're going to bring the 3y down equals negative 4x plus 9. Now, again, we still want y to be by itself. So we're going to break these two up by dividing. When I divide, I get y equals negative 4/3 x plus 9/3. Ta-da! We're finished. We took the same equation, we solved it, or rearranged it for x here, rearranged it for y here. So we're going to do a couple more just so you get the feel of it and you have some more examples to come back to. So let's take number 7. So on number 7, we have 4x plus 12y equals 36. We want to solve for y, or isolate y, right? Isolate y. So we want this y to be all positive and lonesome when we're finished with them. So we're going to draw the line. We're going to treat whatever's added or subtracted next to it, we're going to treat it as a constant. So we want it to go across the equal sign. So 4x minus 4x is 0, and we have negative 4x plus 36. I've got 12y equals negative 4x plus 36. I still want to isolate this little guy here, okay? So it's multiplying by the 12, so I want to divide. Y equals negative 4/12 x plus 3. 36 divided by 12 is 3. Now we could still simplify this. Y equals negative 1/3 x plus 3. Super simple. If you did this on a test, that's fine. If you did y equals negative 4/12 x plus 36/12 on a test, fine. If you simplify it all the way down, awesome, because this is what it would look like on a state exam. And if we can get here by May, that would be great. Okay, let me try something like this one, number 10. So this one has 4y equals 20x minus 8. Well, I want this y to be by itself, and the only thing that's hindering it is the 4, and it's multiplied together, so I'm going to divide. So I get y equals 20 divided by 4 is 5x minus 8 divided by 4, which is 2. There we go. We're finished. Okay, let's look at number 12. I've got negative 5y minus 6x plus 4y equals 18. I see that I can combine some like terms there. I've got a negative 5y and a positive 4y. So that gives me a negative y minus 6x equals 18. Okay, because negative 5 plus 4 is negative 1. If you want to write the 1 there, you can. I don't write the 1 there because there's no reason to. It's just extra work. Okay, so we're going to solve for this y, which means that I've got to get this 6x moved over. We're going to treat it like a constant, so it's negative, so we want to add it. We're going to get negative y equals 6x plus 18. Now remember, it's like a negative 1 there, so we still want to get y positive and lonesome, so we get y equals negative 6x minus 18. Positive divided by a negative is a negative. Positive divided by a negative is a negative. Okay, let's see here. I'm going to do this one more on number 9, just for good measure. It's going to end up looking a lot like this one, but not exactly. So I want to get y by itself, okay? This 8x is added to it. So I need to move the 8x over. So I get negative 8x plus 20 equals 4y. I want to divide by 4 to get y by itself. And I get negative 2x plus 5 equals y. Can you turn that around? Sure. Y equals negative 2x plus 5. Okay. I hope this helps. Remember that you're rewriting or rearranging an equation. You're not necessarily quote unquote solving for it, but sometimes we say solve for y because we want y to be isolated. We want to isolate that variable. Y'all have an awesome day.